Okay, Specialist Mathematics Tech Active Paper 2023. We're going through the questions and we're doing question 15, which is another stats question. Travel time for students attending a certain university is assumed to be normally distributed with a population mean of 25.2 minutes, standard deviation 4.7. Travel times are collected for a random sample of 120 of these students, used to calculate the sample mean of x1 in minutes. Determine x1 less than 25. We're normally distributed. We have a mean of 25.2, 25. We want to find less than. We know that our standard deviation, remember, because for a sample mean, is our rule off our rule sheet. So that's going to be our 4.7 over square root of 120. 4.7 was the standard deviation with the population. Random sample has a size of 120. We are going to do this on our calculator. So I'm going to go, I'm in my stats mode. And let me just exit out. So we get to stats mode. We go distribution, normal. So let's go through. We're going to go distribution, normal. So I'm just writing it down so we can go through it. We're going to go NCD. We want everything below. Now our lower limit will be 0. Our upper limit is 25. So 0 to 25. Our standard deviation is 4.7 over the square root of 120. Calculator works it out for you if you wanted to write it there, 0.429. And our population mean is 25.2. Execute. So our probability, x bar less than or equal to 25, x bar 1 I should say, is 0.32. And that's my answer there. You do get a mark for making sure that you've used the sample standard deviation, and then you'll get a mark for that because it was a 2-mark question. So very much emphasis that you do show that. Given that x bar bigger than or equal to k equals 0.9, find k. I'm a picture person. So we're actually looking at bigger than k. So some k here, this is 0.9. Yes, it is. So we're going to go back to our stats distribution, still normal, but we're doing an inverse, aren't we? Now, which way is our tail going? Our tail is on the right is what we want. So I'm going to go down here, I'm going to go right tail. The area I want is 0.9. Do love the carryover, the sample mean and the sample standard deviation and the mean are there. Leave them. And so we get k equals 24.65. That was just a 1-mark question, so you just had to get the answer to that. Now, coming down to part C. Part C is trickier. It's 4 marks, so we know it's trickier, don't we? Travel times are collected for a second random sample of university students and used to calculate a second sample mean x2 in minutes. Now, given that x2 less than 25 is approximately 0.4, determine the number of students in the second sample. So, picture-wise, oops, that's really dodgy. Normal, isn't it? So we know our mean is 25.2. Here's 25. Less than 25.4. Exit. Distribution, normal. Inverse. I want to know what 0.4 is as a z-score. I want to know 0.4. I want to know its z-score. I'll show you why in a minute. But so to find the z-score, I'm going to go a left areas. Oh man, sorry, I messed up. Left 0.4. For a standard Z score, we go standard deviation 1, mean 0. There may be other ways of doing this, but this is how I do it. You know, also what your calculator is capable of. So that's actually giving me the Z score. Now you know that the Z is your X2 mean. Take your population mean divided by your standard deviation. So then that's negative 0.253 equals 25. Take 25.2 over the 4.7 over square root of n. We do not know what n is. Now, you could rearrange that on your calculator. I'm just going to go and just solve n it, hey? That'll probably be the way to go. I'm just going to delete all on there so I've got a nice clean screen for you. So options, calc, solve n. Negative 0.253 equals over 25, take 25.2 over on the bottom 4.7 over shift square root x. Close my brackets, execute, and I get n equals 35.35. So sample size 35. That was a bit trickier, hey? A bit more involved with what we're doing. I do know that finding the Z score got you a mark with QCAA. Showing that got you the mark for QCAA. Having the decimal, but then also rounding it to 35 is where they attributed their full marks. Okay, that was question 15.